Good morning. Are you able to hear me? At least one yes from your side.
Yes,
Yes, sir.
Very good morning. Yeah,
good
as soon
morning,
as
sir.
you joined, we were moving to an online mode. Okay, let others can also join. Sorry, yesterday I could not able to make it positive. I'm making these Zoom classes an online and also an streamline through the YouTube. I will share the chart. If you want, you can copy it. This is available even after your class. Okay. Very warm welcome to all of you to the Department of Physics and Bangalore University. It is a great pleasure also for us to be with you for another 2 years and making you in a good shape in learning physics, particularly the some of the basic concepts in physics. We can't teach everything whatever you want in master degree, and master degree is in such a way that always you have to have some glimpse of the topics that can be dealt with some concepts, either classical mechanics or statistical mechanics or quantum mechanics or even mathematical methods, electrodynamics, so many branches you can take. Even something like that, some spectroscopic aspects, parts of view, and astronomy part, atmospheric, space, planetary physics, nuclear physics, particle physics, condensed matter, or even solid state, even metal characteristics, nanomaterials, so many things. What I want to say is that for me, the department has assigned the syllabus. I hope all of you are having a copy of the syllabus. No need, at least to take a at least take one set of syllabus, about 5 pages, particularly on theory part, starting from P101 to P105. And we are having a 4 laboratory component, 2 for general lab, optics and general lab, and another one electronics and computer lab to a great extent. Uh, I hope 48 are there, no issue. I will try to share the screen instead of starting. I will give the glimpse. I hope all of you are comfortable in Zoom. Even if you raise your hands by showing the screenshots like reactions, that's okay. If you go to the reactions, there is a hand. I can understand at least, okay, you are comfortable. Have you faced any difficulty in and joining this class? Because this is is and licensed version. Why I want to say that no need to have the login always. One link will come to your email. That link you can have it. Otherwise, in the Zoom, whenever you log in, that upcoming events will come. Just you click on the link that is valid throughout this semester. Fine, fine, no issue. Yeah, we will learn. It is only a practice only. It is not a great task. Of course, you are also there in the pandemic for last 2 years, where you were almost second year and the third year of your graduation was in the pandemic with online classes. I don't know how much extent you utilized because of the connectivity issues only in India. Otherwise, if there are no connectivity issues, online classes appears to be a good. And of course, if you are handling with your relatively a larger display in the screen size instead of using the mobile, if you are having a tab or maybe a laptop or a computer, online classes are far better. US and other countries, Western countries have moved ahead of the online mode because where they can deliver a lot rather than spending time on writing on the board, we can put our time for exchanging the information, for discussing the information, for tackling the information information. Okay, that's fine. But some subjects like quantum mechanics, mathematical methods, even in classical or even circuitry part of it, actually, we may not be able to go ahead only with the online mode. We may not follow it up actually. I'll share the screen. There is an option called at the bottom actually. It can be shared. I will show you that today at least what they have assigned for me. This is the YouTube streamline which is going on. Okay, it will be here. Yeah, you are also available here actually. I will minimize this control boards. Are you able to see the font, see the display?
Yes, sir.
Yes, sir.
Yeah. Okay, no issue, no issue. Okay. Mine is that actually say even though they have given syllabus, I classified or maybe I made it convenient to me and also for you also. Divided this unit into one of the unit, one unit, first unit, second unit only I'm handling into subtopics. That is the classical mechanics is the branch actually where you can have the properties of the motion or movement or float you can call or displacement or the change in the position of the objects with reference to the time. The particles or maybe the objects including celestial objects may not be constant with reference to the position. They change their position from time to time actually. One has to see that how that properties can be understood in physics part of it. Physics is a great subject. You have to love it very to a great extent. Unless you like it, unless you put your efforts with enthusiasm in learning the subject, it is difficult actually. Difficult in the sense that it may not be a bit difficult for you if you don't like it. Maybe all topics may not be of the same kind. Okay, most of the part, maybe some of them may be a complex. You try to put a little bit more effort to learn. If they are relatively easier, that also depends on your enthusiasm and curiosity to learn the subject. Certainly, you will grasp it. I'm sure that there is no doubt you will perform in a better way and try to understand the phenomena to great extent. Okay, be comfortable with the subject, be comfortable even for discussion actually, either during class, even after the class also. We are all available. At least for my case is considered, take it from my side in such a way. Be with you for always, okay, for academic issues and even for something like even any doubts relating regarding the laboratory components or something also will help you actually. Okay. This is the central force. That is in the central force. All four you learned so many forces actually. Let it be a central force. The number whatever I'm showing 14. I may require 14 classes to a great extent. At most 13 hours is assigned a topic actually. Okay, and maybe 1 or 2 hours extra is good enough. Sometimes even we can go ahead of the allotted hours depending on your interest and enthusiasm in learning. Normally, I will keep in on interactive mode during offline classes. Online classes also, if you are comfortable, you can raise the question, you can ask also the questions. No doubt, we will permit. Okay. Here, the central forces are there. No need to describe with the syllabus. My intention is that how one can do it actually. Okay. Reduction of two particle equations of motion to the equivalent one body problem. See, there are some two objects. Those two objects are in motion. Those two objects are also under mutual attraction to each other. Then two body problem can be converted to a one body problem, or the two body problem in the sense, don't take it as a numerical problem always actually. A system of two body, if it is under mutual attraction, acts like only a single body that we'll see later actually. Okay, it is not a big task. Maybe in your graduation also you might have worked out with that classical mechanics part of it actually, where while learning the kinetics, laws of motion, Kepler's laws, Newton laws, gravitation laws. That's all. There are only the few Newton laws, gravitation law, of course, Newton's laws of motion. There is three laws: gravitation law, universal gravitation law. Okay, fourth one, maybe the Kepler's problem, maybe three Kepler's laws. Maybe one is the inverse square law, how that the force or magnitude changes with reference to the two-body problem of that kind. Only those laws are essential in classical mechanics to understand the problem or the issues. Okay, in the central force is an introductory part, we can take it up, and reduction of the two particle equations of motion to the equivalent one body problem. In third one, reduce the mass of the system. See, if you keep the two objects put together, if they are under mutual attraction, particularly gravitational force of attraction, their mass will reduce. Okay, there are four fundamental forces which are acting Maybe if there is a fifth one, maybe try to have it and have an explanation for that. It is a good for the physicist actually to learn more. That is the new either nuclear force, or maybe the gravitational force, or maybe the van der Waals force, or maybe the Coulomb force. These are the four fundamental forces they can call. Reduced mass means, for example, if you take a two potato, take the mass of those two potatoes, means for example weight only, need not be mass, okay, and add them together, put them together, tie it up, take the mass. If you make it as a combined system, the mass of the two, a single system which was bound, should have the reduced mass, means it should not be an equivalent. Or instead of to assume that you take 10 potatoes or maybe 10 tomatoes, 10 apple, okay, put them together, take the total weight. Individually you weigh them. If you take sum of all the masses of all the potatoes put together, differ from the total mass of the all potatoes put together. That is of course when it is happening classical mechanics, that we will see that actually why it has to happen of that kind. What kind of a thing? For example, if I take the mass of a Jupiter and the Earth, and if I take the mass of the Jupiter and Earth put together, should differ. Of course, Jupiter and Earth, whether bound system or not, we have to see. Certainly, the Earth and Moon are bound. Moon revolves around the Earth. Earth revolves around the Sun. Earth and Moon together revolves around the Sun. If you take the position of the Earth with reference to the Sun, it is at some distance. Maybe you can call it as an 150 million kilometer on average. That is mainly because of the existence of the Moon. If you remove the Moon from your theoretical part, you can't expect the position of the Moon at 150 million kilometer. It may be relatively moving either outward or inward. We will check it up. If it moves outward, it becomes cooler planet. If it moves inward towards the Sun, it becomes hotter planet. Neither the type, either hotter than now what we are, or cooler than what we are, life on Earth becomes miserable. See, it comes to the even the classical mechanics problems also comes to the biological issues and the life existing on Earth, even on other planets too, together, whether maybe a human being or not, we have to check it out. Based on that, there will be a conservation theorem. Maybe first integrals of the motion one has to do that, a small derivation out of it actually. I am sure that all of you like more derivative part, because starting from the assumptions, starting from some guess, starting from theorem, starting from some definitions, you will start with some concept. Then you are deriving the concept in such a way that you will come for some final expressions where that gives us that what we want out of it. Then maybe in the examinations, if you are more keen on only for concentrating for the exams to score, that is more trivial also, it is required, there is no doubt. Maybe they may ask for show that or prove that, arrive for the expressions, obtain an expression, any theory, type of theories you like it. Those theories or theorems we can call actually, theories we need to solve the problems in physics which is of more relevance particularly to the practical applications which are happening in and around us and are even for our comfortness actually. Why we have to send a satellite to the moon? Why we have to send a satellite to the Mars? Why we have to send a satellite to the Jupiter? Why we have to go for a space journey? Why we have to go for an international station of about 500 crores put together? That we'll see that at least. Okay. Indian Space Research Organization has put a tremendous effort in achieving all those all those things in the sense, all those objects which can be handled. Fourth one, I am saying that equations of motion of the for the orbit, of course, that you can say that electrons are revolving around an nuclei, making it as an atom, or even similar fashion. You can have the planets are revolving around the sun, and sun and the sun or maybe stars are revolving around the some common center of frame or some common center of mass as the galaxy that we think it up. Then one has to go with the classification of the orbits. Either elliptical or maybe in horizontal or maybe ecliptic. Such type of classifications we have to see that, and which are the more stable orbits. And also one can arrive for the conditions for the closed orbits. Two classifications will come: closed orbit and open orbit of that kind. Maybe closed bracket and open bracket you might have seen in mathematics actually, while or maybe parenthesis also they can say that actually. In the fifth topic, we were having something in the bracket. inverse square law force. Is it open bracket or closed bracket? Is it open? Just raise your hand. Is it open? Or is it closed? If I ask two questions, a bit tough task, think it up. Go for the classifications of the brackets. They will call it as braces, like open, closed, flower bracket, square bracket, or maybe different kind of a braces. One has to utilize the Bodmas rule, BODMAS, Bodmas rule, for either opening or closing of the braces put together in particular direction. That is some conditions are there for the closed orbit. What are the closed orbits? For the stability of the orbits, for stability of the universe, for stability of an atom, or even for the stability of a molecule, one has to see that. Fifth topic goes with the Kepler problem. Kepler was a great scientist, okay, who made a contribution, great contribution in understanding the phenomena of movement of the planets around the sun, or maybe around a star of that kind. Actually, there are three Kepler laws. They define they define the position of the planets with reference to the time. They also tell us the position of the planets with each other. Even the planets in a position of the planets in solar systems, where one can arrive for the inverse square law force also. As you move away from the source, what will happen to the force which is acting? Of course, when you say that the position of the planets, either like Saturn or maybe Uranus or maybe Jupiter or maybe a Mercury or maybe Earth or maybe the position of you on the Earth, actually, even astronomically fine, one can able to tell it. Astrology people will also tell with the fate whether we should have an experimental evidences for such type of the things one has to be. Unless until while believing those type of the concepts, you should have a strong background in science behind it. This is the first part of it. Maybe the first unit is second unit only. Maybe where I'm handling is the first is the second unit of the classical mechanics. Okay, in the first paper. Second portion or the middle portion, you can say that. In the central forces only, central forces can be defined with the central force, the properties, or the scattering of a particle in a central force field. Okay, then the same thing with the motion in non-central reference frames one has to discuss. Scattering in a central force field, for example, goes with some general description of the scattering phenomena, how the objects or particles are get scattered when they are under the influence of central force, like a gravitational force. Okay, if some meteorites are coming and moving, actually, they may be, if they are near to the earth, what will happen? If they are near to the moon, what will happen? If they are near to the sun, what will happen? Okay, maybe some satellites, if they are approaching the distance rather than what they are put into the desired orbits, what will happen? If they are moving away from the desired orbits, what will happen? One has to see that. Like that, a general description of the scattering phenomena. And there itself, we can have some two topics: cross section for the central force field and impact parameters they can come, that we will discuss in detail. Actually, one great scientist you might have heard, actually, particularly Rutherford scattering, known as Rutherford alpha scattering, they can call it Rutherford alpha scattering, they can call Rutherford alpha scattering for the scattering phenomena, how that the existence of a nuclei was found during 1930s, almost, and 1 century, 100 years before, 1992 here before right now, how that the nucleus was made at the center part of an atom with the heavier mass concentrate. Most of the mass is concentrating at the center part, actually, and the electrons are revolving around it, where the nucleus is composed of a proton and a neutron, with one charged particle and another one an uncharged particle. Both are bound by the nuclear forces. Here in classical mechanics, again, we will see that how that Rutherford scattering can happen to a great extent. With that, it leads to the two concepts: the center of mass and particularly the coordinate system. There are different coordinate systems, laboratory coordinate system they can call, actually, either Cartesian coordinate system, cylindrical coordinate system, or even spherical coordinate system. Okay, r theta phi, r x y z, or even ABC. You can call them by any name, like x-axis, y-axis, z-axis, or maybe including with the radius component and the angles obtended with the elimination. Or one, if you want to define the celestial bodies, they can call it as an azimuth angle, zenith, then right ascension. Some different terminologies are there. They are also required, actually. They are also required. Based on that, one can have some transformations. Transformations means coming to some mathematical tools of the scattering angle and the cross sections between them. This is the relation, actually. This is the second part, how that scattering scattering plays an important role in the central force field that we will try to learn actually. Okay, and the last one in that actually motion in non-central reference frames. There are two frames of references where the Newton's laws are valid. Newtonian mechanics can be dealt with that. If the Newtonian laws, particularly second law, Newton's second law, if it is not valid, we can call them as the non-Newtonian frame of references. Okay. Now, motion of a particle in a general non-inertial frame of reference. Okay. That will see that properties, how they have to behave. And the notion, there is a terminology they can call of the pseudo force. Pseudo means that is virtual forces, imaginary forces, how they are acting. Maybe a gravitational force or gravitational force is not a pseudo force. Coriolis force. Earth rotates on its own axis and it causes some force. That force is known as the virtual force. Then there should be an equations of motion. Maybe for rotating frame of references, that we'll see that. Earlier also you might have worked with that, particularly in having the expression with the theory of relativity. Here we will not come into the picture of the theory of relativity, how that equations of motions play a role, particularly in rotating and non-rotating frame of references. We'll take the example of the rotating frame of the reference, maybe the Earth, or maybe preferably for the Earth actually, how being an Earth, how one has to observe the satellites. Being in satellite, how one has to observe the movement of the Earth of that kind. Forces like Coriolis force should have a description for that and the importance of the Coriolis force, how it acts. And the deviation due to east of a falling body means due to the Coriolis force, objects will not move straight, equatorward. Okay, they are changing their original path, moving towards the east. That we'll see that one pendulum experiment will come that they can call it as an Foucault pendulum. We may not have that in the laboratory, but still we can have the discussions. This is as per the discussion for the second unit to consider. Let us see the next one. Okay, I hope you can see this. I'm also asked to teach you another unit in the fourth paper. That is the last unit, fourth unit actually. The paper is on mathematical methods of physics. You are great mathematicians, I am sure that. That is why without the understanding of mathematical concepts, physics becomes tough task. You feel that physics is a relatively a tougher subject, tougher in the sense for understanding, not because of the concepts which are arises from physics, but because of the mathematical component which inculcate, which introduced, makes you an uncomfortable to some extent, provided if you don't have a proper understanding in your mathematics. Okay, try to learn. We are not teaching hardcore mathematics like an algebra or something like that, but we are going with preferably in either maybe solving the solutions, simple solutions, either from matrix method or from linear equations, or maybe solving of some integrals, solving of some differential equations, maybe like either ordinary differential equation or maybe a partial differential equations, or maybe getting the solutions or maybe the roots of some of the equations by some technique or some methods of that kind. Here, this unit is made into two parts. Okay, did not be for the three. The first part, starting from 1 to 8, goes with the C programming. Okay, we have to learn. We have to learn certain skills actually. C programming is the basic programming it is used for you actually. Of course, you might have also worked out in your graduation about the C programming. About the C programming. Okay. But compared to the other programs like either Fortran or maybe Pascal or maybe Python or maybe a Java or any languages of that kind, C is relatively a basic and fundamental program, which is mainly opted to have an particular operating systems like Unix. To develop an Unix, a Rishi has developed a program. That program is called C. Instead of it is relatively a low-end program, okay, but one can learn if you have already learned well and good. If you are alone having an expertise in C programming with having a capability to solve some mathematical functions, mathematical equations, and also to address, not solve actually, address some physics problems, you will have a great opportunity in terms of the jobs. You are also having a great opportunity in research career if you are having a good programmer. Programming need not be done alone to have some repetitivity. It should have some skills of handling the both numerical and concept oriented problems to obtain the solutions and also to have the to have the solutions for any kind of real problems. First eight topics, it may not go with everyone actually of that kind. We will move relatively faster. C programming, particularly introduction to some compiler and interpreter, we'll discuss. Constants and variables, they can say that how they are varying, how they affect actually, and how that constants are defined in a program, how that constants are defined. Need not be for C, it's in general. Okay. And variables, some of them are variable quantities of that kind. Arithmetic operations, whatever you are getting in mathematics, the same arithmetic operations will be there, like addition, subtraction, multiplication, division, less than, equal to, greater than, equal to, approximately equal to, okay, maybe not equal to, less than, not equal to, not greater than, not less than, maybe variable, maybe equal to zero, maybe approaches zero, of that kind. Several. There are several things of that kind. Then one can classify the data types also, maybe like an integer, non-integer, real, or transcendental, or sinusoidal, or maybe a logarithmic. Okay, simpler to say that. You will enjoy this unit to a great extent. I'm sure of it actually. Okay, while giving something to the computer, we should have some formats or some syntax, or can call some rules they can go where the inputs and output actually how that statements can be written. I can't say the same English language what I'm using and what you are also using, the same way we can't be fed into that. Maybe either in Kannada or maybe English or Arabian or any language of that kind. The computer will not understand what language you are speaking. The computers are the machines they can call. They understand a different language, how that information can be fed. Okay, they can understand only either in terms of the current and voltage. They can call lows and ups or zeros and ones and zeros of that kind, how that particular in digital era of that kind. And then some control statements. Control means where to stop, where to control the things actually. That will try to see that at least. Okay. Then switch statements. Switch in the sense like an electric switch. There should also be a switch in the programmer. Okay, that can be switching between the two statements, switching between the two concepts, switching between the two ideas, switching between the two logics. They can call actually loop statements like for loop, if loop, do while loop. So many things are there. Okay, so many means the same thing what I told about 4 or 5 of that kind. Okay, and some format specifications to get a print, how one format one has to do that. To get an output, how to do that. To give an input, what format we have to use. To get an output, what format we have to do that. And to get a printout of a statement, how one has to do that. There will be some arrays instead of some logical, only single values. If there are a group, how one has to feed. Some algorithms, it is a systematic way of transforming the information ideas into a computer coded language. This should be requirement of the algorithm. Based on algorithm, they can write some charts, flow charts they can call, how that the problem should be solved, starting from initial ideas, and then giving something as an input, then executing with the synthetical concepts, and maybe the criteria that should be followed, criteria that should be adopted, then should be end of the program to a great extent. Then different functions will be there that we see that. After some awareness with the 5 items they can call, one can write simple programs actually. Like for example, to estimate the area of a triangle of any dimension or any angle of that kind actually. And we check that whether the given character is maybe vowel or maybe consonant using the switch statements they can call. He can do it if also, he can do loops also. Maybe computing the sum of the given numbers, maybe integer, even fraction, real numbers, even float, making an average, maybe simple task, particularly make you to practice with the logics actually, and we will solve with that how that Fibonacci series works using while loop. Fibonacci series is a fantastic series. You'll get a set of numbers arranged in a particular fashion, and sorting of the numbers either in increasing order or maybe decreasing order or maybe in random order. Okay, and estimating the value of, or not estimating, calculating the value of the factorials, addition of some two matrices is relatively actually a tough task, but still we can do that. How two matrices can be added using the arrays, maybe either 2 cross 2 matrix or maybe 3 cross 3, either triangular matrix or maybe a square matrix or maybe a rectangular matrix. That we'll see that actually. We'll not study the properties of the matrix, but how that addition can go. 2 cross 2, any square matrix can be added together. There is no doubt. 3 cross 3 can be added. N cross n can be added. All the computers and the compilers, for example, works much efficiently with the matrices to a great extent. If it is a rectangular matrix, how it can be handled, that one has to see that. Using these things and also mathematical tool, we are having some 5 topics, okay, main 5 topics to solve some problems that should have link with the physics part of it actually to obtain solution. Okay, so we want to know the solution or maybe the roots you are calling actually by some techniques they can call. I am sure that in mathematics you might have solved these techniques. I may not put much time for you to take you to the solving the Newton-Raphson method or bisection method. By making use of the Newton-Raphson method and bisection method, it can solve some problems. What kind of a problems? We will see that at least. Okay, and solving a system of linear equations using the Gauss elimination method. This is a matrix method actually. We are going eliminating the sum of the elements in the matrix and finally we'll arrive for the solution out of it. One of the element. If it is a 3 cross 3, for example, like x1, x2, x3 are the variable quantity. If you know the x3, by substituting that into the x2, you will get to the x2, then maybe x1 of that kind. Either forward technique method or maybe reverse technique, the forward elimination or backward substitution method they can call. Two methods are there. We will try to see that at least. Okay, and one can evaluate the integrals. You are we are well aware of the integrals. You scored very well in your mathematics and also physics too, mainly because of your strong background in mathematics to a great extent in solving the several integral equations and several differential equations. These integrals can be solved using some two techniques they can call actually Simpson's rule, that is 1/3 and 3/8. 3 are there, and trapezoidal. In fact, the trapezoidal rule is a fundamental rule in solving the integral. From based on trapezoidal, one can go for the Simpson's 1/3 and 2/3, 3/8 rule of that kind. And one can solve the ordinary differential equations from either Euler and Runge-Kutta. Euler method is also simpler method actually to solve. And Runge-Kutta, there are two techniques here. Maybe different orders of magnitude they can go, either second order differential equation or maybe fourth order differential equation of that kind. Not the same differential equation order. Second order Runge-Kutta method and fourth order Runge-Kutta methods are the one where they can use it for the solving the differential equations. But computers will never handle neither differentiations nor integrals. There should be a technique to add. They can go with only algebraic equations, either like arithmetic operations, either addition, subtraction, multiplication, and division to a great extent. Okay, only we will use those type of the things to arrive for either integral or maybe for the differential equations. Then finding some least square fit method, you solve so many things while doing the graphs. You will have a two set of values. So set of values actually, then you will find the correlation between them by making use of the least square fit method. Lagrange's interpolation technique is the one, and how then one can go for the interpolation technique. Okay, but if you are good in programming and if you are having a proper understanding of the mathematical aspects and making that mathematical aspects to solve the physical problems, you'll become a good programmer. Not like a programmer in your computer science or maybe in some other branch of that kind, but you'll become a good programmer to a great extent. Even people, particularly so many laboratories are hiring, so many multinational companies are hiring people with a very good background in programming, and they can solve array for certain physical problems to a great extent. This is with the second part. Okay, they have assigned me the 3 units actually. I'm handling the 3 papers out of 3 papers, 3 units in 3 different papers out of 5 papers. Almost 60% coverage will be there. Okay, last one, it is very particular. Yeah,
sir, this is physics or mathematics?
This is the physics you will learn. We are using the mathematical tools mathematical tools to arrive for the physics solutions. We'll address the problems in physics, but there is no difference between what you are learned in mathematics and what you are going to learn in physics. There is no difference. Techniques are same. What those techniques we will use it for solving the physical problems. Maybe putting a satellite in a particular orbit in the on the Earth's atmosphere, or putting a satellite into Mars, putting a satellite into Jupiter, or sending a satellite to somewhere else. What kind of an equations one has to use that? For example, if you want to estimate the mass of the Earth, actually, of course, you might have made the weight of a potato, weight of a tomato, weight of something else. If you want to estimate the weight of an entire planet or mass of an entire planet, actually, you can't have any simple weighing machines. There should be some techniques to use it. What are all those techniques? We'll see that at least. That's such type of things. And all problems which are relatively complex or gets converted to an matrix method first, those matrices can be solved to obtain the solutions. Those solutions are, that is the mathematical solutions are the solutions for your physical problem. Maybe for example, if you are having a heat source, the temperature go on increasing by 1 degree for every 1 minute. Assume that after 100 minutes what will happen? Assume that you are starting with 0, it has to have 100 degrees Celsius, for example. If you go for 120 minutes, it may go for 120 degree, provided your mathematics says that if you increase the temperature by every 1 degree and you start with at 0, and after 120 minutes the temperature of the substance should be 120 degree. Let us choose the water as an example as a system, but can we take that water to more than 100 degree? Being a physics, you are well aware that water boils at 100 degree, maybe 99 to 101 degree, depending on the pressure where you are there, either over Mount Everest, Himalaya, or maybe on the Earth, that is over equator, or maybe some on the top of the mountain. If the pressure differs, maybe instead of one standard atmosphere, if the atmospheric pressure differs, the boiling point of liquid will also change. For example, let it be water. Okay, the boiling point of water in a cooker, pressure cooker, is certainly more compared to that of the boiling point of the water in an open system. Such problems we can solve. That is the main intention, actually. But of course, if you are having a good mathematical background, it's no doubt you will learn a lot. Even without that, also, don't get scared out of it. Entire this mathematics concepts makes you a very fundamental and strong in physics. All mathematicians are also in physicists. All mathematicians are also physicists. At the same time, all physicists were also good mathematicians. Otherwise, it is not an easy job for them to arrive for such a great inventions or maybe discoveries. Apart from experimentalists, theoretical physicists are an entire group where they can work a lot. But all experimentalists are also a good theoreticians while working out such type of problems. Thank you. Which the third unit in the third paper, sorry, first unit, maybe in my part it is third unit of that, and I told actually. Okay, we'll go one after that. Here, just I made it as a restriction of 11. I'm having more comfortable and strong background. I'm working in this atmospheric and space physics from last 15 years in this department. We'll take it up in a better way. Basic concepts of atmospheric physics, they can come. What are those concepts? We can come on to picture. And some introductory part to the atmosphere. You are new to this. Maybe those who are studied in Bangalore University might have gone through some topics of atmospheric physics. Okay, maybe where you might have learned it as an atmospheric science. Actually, atmospheric science can be dealt by any of them. Need not be physicist alone. Maybe a mathematician or a chemist or a geographer or maybe a geologist or even environmental or even the non-science disciplines such as some other humanities department also can tackle. But here, these areas we are addressing the physics part of the atmosphere. A great difficulties and complex systems which are existing. Still, we are not in a position to make predictions for our weather systems. We are unable to predict the rainfall properly. We are unable to predict what will happen tomorrow. Either it may be chilled or maybe a cold or maybe a summer, hot or of that kind. We are not sure that when we will get the rain, when we'll get the monsoon season, whether maybe on time or maybe off time of that kind. In countries like in India is a majority with the agricultural issues. Those problems, if you are understanding in a proper way, not the agriculture part of it, we can help them. These applications can be used. These things can be used for several aspects. that in the class duration of the class I will explain with more number of examples which are of more relevance to us rather than from Western and the other countries. Some coordinate systems like Cartesian coordinate system, or let's say cylindrical coordinate system, what we learned in classical mechanics. Here also a coordinate system will be there, either elliptical or maybe horizontal. But how that coordinate system can be used to obtain the position of a person or position of a celestial body in the space, maybe in terms of the latitude and longitude they can call. You might have seen in the globe, on the globe actually, how that the latitude and longitudes are marked. You might have witnessed that how the maps are done, maps are designed actually. Okay, the three-dimensional pictures are written on a two-dimension. It is a tough task. Those type of graphs they can call it as an Mercator graph. And to define or deal with those things, we'll go ahead with the velocity components, like either maybe in the direction of the x or the y or z instead of the x, y, z. For the Earth is considered towards east or west or north or south on two dimension, either maybe vertically upward. Of course, moving downward is restricted unless you are on the top surface of an ocean. Some optical properties, mass of the atmosphere. Of course, you might have taken the mass of the materialistic properties, how one can take the mass of the atmosphere, that will see that how one can measure it or how one can estimate it. Okay. Chemical composition, what it is made up of, whatever may be the number of the elements which are exist on your periodic table, 118 or 120 or 130, just think of it. Day by day, scientific community is continuously making a research and trying to invent some of the elements. Okay, periodic table, if you are referring a book which is of 20-year old, and the recent book may have the different number of periodic number of elements in their periodic table, kindly update it from your side. Then how that vertical structure will go is there should be some structure actually for the atmosphere, maybe in terms of the pressure or maybe in terms of the density or in terms of the temperature. Here also you'll get some mean free path, that is the time taken for the two molecules to collide, or maybe the distance between the two molecules, how much they are separated before they are colliding, because that depends on the density and the pressure of the atmosphere. I don't know whether you may be aware of it or not. Most certainly we will discuss. If you go vertically upward about 400, 500 kilometer, each molecules are separated by few tens of kilometers. Still, if you go for 1,000 kilometer, each molecules are separated by about few hundred kilometers. Each molecules are separated by few hundred kilometers. At about 800 to 1,000 kilometer, the temperature comes to be rise to be around few thousand degrees Celsius, about 1,500 degrees Celsius. If the satellites are moving at that height, can we expect that they can sustain a temperature of about 1,500 degree is a question we'll try to attempt. Then maybe winds in the atmosphere. Winds means either easterly wind or northerly wind, or southerly wind, or even jet streams they can call. Precipitation is nothing but amount of the rain, how that rainfall can occur actually, either fog or mist or rain. Different laws are there, like the thermodynamic atmospheric gas laws, ideal gas laws. Temperature also acts like an virtual temperature. How that virtual temperature plays with the adiabatic temperature, we'll see that. Some two equations will come into the picture, hydrostatic and hypsometric equations. Those two equations represent the atmosphere in a better way, and you can able to scale them with some different height. That height they can call it as a scale height. Based on that, you can have the thickness of the atmosphere and height of the constant pressure surfaces, okay, and reduction of the pressure to the sea level. We will have a pressure of some several hectopascals, what I told. Reduction of the pressure to the sea level about 1013 hectopascal or 1013 millibar, they can call. How they can arrive? Of course, it can go for about 11 classes of that kind. That we will try to keep it up. Actually. Let's put together 3 units, and I will also handle computer lab for you. Few batches I can call actually. This time, means together, this is about 75 marks. Computer lab about 55 marks, 50 marks, about 125 marks out of 700. Almost I am taking about 18% of your curricula, what it is prescribed for you actually. If you are good enough and if you are comfortable with this subject, it is not a big task for you to score minimum 70% in all the papers. Try to make it maximum effort, and you will get, even will not deduct single mark if you write properly, if you address the problems or properly to a great extent. It's fine. Maybe from tomorrow we will go with the offline classes. We will meet physically rather than for the online mode. And in the laboratory, particularly in the computer lab, I will guide you actually. This time we have to do, this is the first batch actually. This is the first time we want to make you an exposure to the basics of the computer, basics of the computer programming they can call, handling with the some equations in solving, either maybe making use of any of the spreadsheets, either Excel or whatever you can call. In MS Office they can call it as an Excel. If you are using the Linux platform or maybe a Unix platform, maybe there may be different kind of spreadsheets. That one has to see that, and some documentations how they can make. Maybe simply it's not the problem with the typing, but how that can be arranged on the other part. That's on some second, and we'll also teach you that how some small programs can be written by making use of the C. What I told few topics in the first. Sorry here. 1 to 8 is there, no? Yeah. 1 to 8 here is there. These things we will solve it at least maybe about some 2-3 labs. 2-3 labs is more than sufficient for us actually. And we'll also learn one more not software, one more typesetting tool they can call LaTeX, later version of the tech mode they can call a perfect documentation tool actually. In the fourth semester, you are having a project to be executed from your end, and that project should be reported well. To have a report, if you are having going with some LaTeX tool, like a tool like a LaTeX, that helps you in a better way. You will enjoy the documentation, the output of the document, which is coming out of the LaTeX compared to either Word or maybe some other processor which are used for desktop printing purpose of that kind. Time being, hope I may want to convey this to you. Maybe tomorrow at regular hours, I will take the regular class actually.
Excuse me, sir.
Yes.
Yes, sir. This is Naresh.
Uh,
I had a doubt.
uh,
So, what are the uses of this paper? Only exam purpose or anything?
no, which papers?
These papers.
These three.
Yes, sir.
No exam purpose. Oh, you will find the n number of the applications for every topic, starting from beginning till the end. Actually, how we are using, we have to say that at least by studying the scattering, what properties we can study, what is the technology we have developed, what are all the applications we are using for it at least. These are very much required for the essence of the life. Essence of the life. Without
Oh,
understanding.
yes, sir. Yes.
Yeah, maybe one after the other we can take it up rather than giving only 2 or 3 examples of that kind. We will certainly go ahead actually. See, whatever the mobile we are handling right now is the evolvement of a technology and science. The signal you are receiving is the evolvement of the technology and science, and the what we can call they addressed most of the fundamental problems in physics or basic science they can call actually in general actually. Unless you address those problems, you may not be having in a position actually. Otherwise, talking to you over a long distance without interruption and without losing much power, much energy was a tough task. Tough task. Okay. We will see that the examples can be dealt in classrooms. It's far better, of course, wherever you want actually. If not on the offline mode, certainly we'll go ahead with the online mode. Make use of the same ID and other things. That ID is valid for throughout this semester. If you are having any doubts, I'm happy to attempt you. Are there any charts? Okay, no issue. If there are no doubts, I will stop sharing screen. Anyone? Ashwini, is it okay right now? Shushma, Subhash, Mahalingaya, Sohama, Chetan, Nishit, Sahana DS, Ramya, Yashaswini, Kundangam, Trupti, Bhuvaneshwari, Lakshmi Devi, Yashaswini, Sumaya, Mohan, Chaitanya, Chaitra TS, Chetan,
Present, sir.
Pooja, Venkatesh, Sahana,
Yes, sir.
Anusha, Geetanjali,
Yes, sir.
Nityashree, Annapurna,
Yes, sir.
Rachana, Aruna, Girish, Shruti, Anjali, Rupa, Monisha, Soumya, Kavya, Supriya. Then who else?
Sir,
Meena.
Kavya, yes, sir.
Yeah, oh, no problem. It is not. I'm not calling for attendance. Just I thought that names. Meena has raised a hand. Do you have any query? Okay. Thank you. We will see tomorrow. Be come with safety actually, and have a strict measure of the COVIDs. You should not be affected at any cost, and it should not be prompted. Thank you. Thank you, Anada.
Okay, thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.